Hey everybody, I just wanted to make a quick video on proving the power rule. This is something I did really early on in my channel, but I didn't really like that video. It's just it was one of my first videos, so whatever. I did that using a very different method, but this time I think this is a way more legitimate method. So yeah, let's just get started. Basically, we're going to be using the connection between the sum and the product. I actually made a whole video on that, and I went from how we got this all the way down to here, this result. So if you don't understand this, then definitely watch that video. That'll explain everything for you. But yeah, so using what we've learned here, we can start to think about other things. So we know that x to the n, just that, it's an exponent, so you're multiplying x n times. So since we have this equality, this is actually like a definition here. We can write it like that. There, it's like a definition. Then x to the n is equal to the pi product of our x, but with like a top up here as n. Now we don't have like any index here because we don't need it. We don't actually have anything to index. They're all x's. So there's no index. There's not necessarily a first number, it's just we only care about this number up here. This is x to the n power, basically, just another way to write it using our pi notation. So we're going to let all of our f of x's with all of our i's, because here we have our index as I and our f sub I of x. Basically, all of our i's are just going to be they don't really matter anymore because all of our functions with the index I are just going to be x. So we're gonna turn this into this just by using this little fact here. So basically, the derivative of let me write that D a little better here. We're just going to be taking the derivative of this, right? So this is going to be the pi of our n's with all of our x's here, right? And this, we can just make it equal to that. So this is equal to pi n x here, basically literally just itself, and then times the sigma, again with our n up top, of what is the derivative of x? It's just 1, right? So we got 1 over x, again, we just put it here. And so this is really cool because what we know is that this we just said was that. So this is x to the n. But then what is this? Well, this, if this is like an exponent type thing, like a rewritten exponent, then this is a rewritten multiplication, right? Because that's just how sums are. Multiplication is like repeated sums, and that's basically what that is. So we're going to multiply this n times the 1 over x. And this is starting to look familiar, right? Because now we have this as x to the n times n over x. And then, actually, that really wasn't that useful at all. We can write this as n times x to the negative 1, right? And so, because 1 over x is just x to the negative 1. So then we can regroup things, so we can put the n out front, then we can have this x here, and then we get n minus 1 if we just multiply these together. And this is the power rule. This is exactly the derivative of x to the n. It's equal to n times x to the n minus 1. And that's it. That's our little proof here. So if you can understand this, if you can understand what we did, it's actually pretty simple. It's really not that hard at all. And we didn't even have to use the whole limit definition, which makes things really crazy because you have to use the binomial theorem and all this and that. And I don't really understand it that well, so I'm not going to make a video on that. But I really like this proof, and I really hope you enjoyed it too. Thank you for watching, and I hope to see you in the next video. Bye, guys.